Dun, 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 dun. Dun, 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 dun. Hola, hola, hola. Hola, hola, hola. Okay, let me see if it is still echoing. Is it still echoing? I don't think it is anymore. 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 Hello, 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 hello. I think that's going to be fine. Maybe if I put it, I think 24 is really good. I think that's going to be fine. Maybe if I put it, I think 24 is really good. I think that's going to be fine. Back to coding.
And optional modifiers to format the output by using.
Rewrite the information. Format specifier, a special token that begins with a percentage symbol followed by a character to specify the data type and optional modifiers with precision flags. The control data is displayed.
Format specifiers. We can control how data is displayed or interpreted. Let me give you a demonstration. We've covered a little bit of format specifiers on the previous topic on variables. Let's say we have an integer variable of age. Set that equal to some age. Then we will have a float. This will be a price. Think of a price. $19.99. Let's say we have a double of pi. A double is also a floating point number, but it has double the precision. However, it takes up more memory. Let's set this equal to the first few digits of pi to keep it simple. 3.14159265535. Then a char. Currency. Pick unit of currency. This has to be within single quotes. I'll pick American dollars. And an array of characters, also known as a string. Maybe name. Type in your name within double quotes. To display these variables using printf, we'll want to use a format specifier, that percent symbol. We'll display the age first. Printf, within double quotes, we will use the percent sign for a format specifier, then D for decimal, comma, our variable age. So D means decimal. This will output 25. For a float, the corresponding letter for the format specifier is F. Printf, %F, we will display our price. Oh, and then we need a new line character. I tend to forget. You probably will too. 25 and 19.99. And a bunch of zeros afterwards. Alright, now for a double, you have two options. We can either use F or LF, meaning long floating point number. Printf, either F or LF. Then that new line character. We will display pi, our variable pi. F also works. You may see people use one or the other. However, when we reach the topic on accepting user input, we can use a function known as scanf, where you'll want to use LF, if we're accepting user input for a double, that is. So just to be consistent, for doubles I like to use LF for both output and input. It helps with consistency and readability. By looking at this variable, I know that this is a double, but for output purposes, F does work too. You can use either, you do you. Now for a char, that's a single character, we'll use %C. I will display currency, that's the name of the variable. There's our symbol. And then for an array of characters, also known as a string, you'll use S. Printf, %S. New line, name, that's the name of our variable. And here's our name. Depending on what you want to display, the % sign is going to be followed by a given character, depending on the data type of what you want to display. And here's a few of the more common data types for beginners. Integers, floats, doubles, chars, and an array of characters, also known as a string. Now we do have a few optional modifiers. So between the % sign and the corresponding letter of the data type, there's special characters we can add to format the output. Here's an example. Here's how we can set the width, when we display our output. This time we'll have...
Hold on, let me go back. Actually, does this even run? Yeah. Alright, then I had, great. Weird. I feel like pi it should. For double, it should continue.
optional modifiers. First, beginners. Depending on what... And here's our name.
I thought it would go for longer. Huh.
Depending on what you want to display, the percent sign is going to be followed by a given character, depending on the data type of what you want to display. And here's a few of the more common data types for beginners. Integers, floats, doubles, chars, and an array of characters, also known as a string. Now we do have a few optional modifiers. So between the percent sign and the corresponding letter of the data type, there's special characters we can add to format the output. Here's an example. Here's how we can set the width when we display our output. This time we'll have three numbers, three integers. Int num1 equals the number 1. Int num2 equals 10. Int num3 equals 100. There's three integer width when we display our output. This time we'll have three numbers, three integers. Int num1 equals the number 1. Int num2 equals 10. Int num3 equals 100. We'll use a few printf statements. We're displaying integers, we need to use %d as the format specifier. I'll add a new line, followed by num1. Then let's copy this printf statement and do the same thing for num2 and num3. We're displaying three integers. Now between the percent and the letter, we can type in a number. The number that we place between these two characters will set the width. For example, 3. The width specifies the minimum number of characters to print. So now we're printing at least 3 characters. 1, 2, 3, including any spaces. So my second number of 10 has 1 space before it. Including any space, printing at number of characters. You can type in a number. 3. I'll add a new line, followed by num1. Then let's copy this printf statement and do the same thing for num2 and num3. We're displaying 3 integers. Now between the percent and the letter, we can type in a number. The number that we place between these two characters will set the width. For example, well, 3. Between these two characters will set the width. For example, 3. The width specifies the minimum number of characters to print. So now we're... printing at least 3 characters. 1, 2, 3, including any spaces. So my second number of 10 has 1 space before it. And with 100, well, it does take up 3 spaces. If I were to change this to 4, let's take a look and see what happens. Now we're printing at least 4 spaces. 1, 2, 3, 4. You can left justify these values by adding a negative sign before the number. Now these numbers are left justified, and we have all the space after. You can also add leading zeros by preceding the number with a 0. Rather than having spaces before each value, we'll have zeros.
If I make it like what if I I guess 0 would be done. I want to do it doesn't get actually giving it a value.
AB num3 is negative. Negative 100. Let's reset these. Before the letter that corresponds to the data type, if you add a plus sign, if the number's positive, you'll have a plus sign. If it's negative, you'll have a negative sign. This could be good for accounting. Now we'll get to precision. We'll need some floating point numbers. Let's say we have following prices. Price 1 equals 19.99.
I'm so confused because if when I use the double inside of the format specifiers, then it's not printing out the long float version of it. Why is it not doing that? Because I'm not specifying how many I want. Like if I say 15. I guess so. I guess it. Alright, let me add that to the bubbles.
Float price 2 equals 1.50, and price 3 equals negative 100.00. To display some floating point numbers, we'll use the format specifier of F for floating point number, followed by a new line character. Let's display price 1, then 2, then 3. Here are the floating point numbers, our prices. The default behavior of C is to display 6 digits after the decimal when displaying a floating point number. Before the corresponding letter for the data type, you can add dot or period, then the amount of digits to display after the decimal. If we're working with prices, 2 would be good to display 2 digits after the decimal. For example, dollars and cents. So let's do 0.2 for each of these. That looks a lot better. We have 19.99, 1.50, and negative 100.00. If this were 0.1, we would display 1 digit after the decimal. Do keep in mind that the output will be rounded if we were to display it. So 19.99 becomes 20.0. Alright, so that's how to set the precision. Add a dot, followed by an amount of digits to display. And with what we've learned, you can combine width, precision, and flags together. Along with our
The fuck is flags?
precision of 0.2, I will also set the minimum amount.
Are those flags the things he was showing you earlier? No, that was part of width. That was flags. A flag, okay, it's programming the term flags most commonly refers to a flag variable. Flag variable is a variable typically an integer or a boolean. What the hell? Wait, it's a signal.
Amount of characters to display. For the minimum width to display, I'll set that to be 7. And then I'll add a plus sign. So any
The flags, is he talking about the plus sign, maybe? I don't know. No. Surprised I can identify that after the point here. Like differentiate the 7, the point. And then let's do the answer. One, two, three, four. That's 2. 1, 2, 3, 4, 5, 6, 7. So let's count. Yeah. Alright. Let's do this counts the plus sign.
positive numbers will have that plus sign preceding the number. So with format specifiers, along with the corresponding data type, you can set the width, precision, and flags. We'll have more practice with this in the future. And well, everybody, those are format specifiers in C.
I think that's good for him. Double the one that I was looking at remember it's like double the amount. That's actually not even too wrong. It's not correct. It's not wrong. Hang on, why does it say anything? Ooh, it looks so cool. Damn, debug output. I'm gonna call it a combination of width, precision, flat. Alright, that's gonna be all for that live stream. Business. Oh wait. Can I if I add this, okay, browse. And then can I twist it or rotate it? Alright. Let's go and do that. Bye. I wish I had outro music.